Okay, okay, students. Today we'll try to do an experiment on installation and analysis of a solar PV system with DC load. Okay, so this is called as electronic charge controller or electronic control circuit. Generally, this is the heart. Okay, you can see here. This is the outer structure. So here you can connect the solar panel positive and negative. So I have been dismantled this and original connections are given in this board. Okay, now let's try to connect this second configuration. So here you can see here. So the input is one is positive of the solar panel, next one is negative of the solar panel, next one positive of the battery, next one negative of the battery. Here you can connect one DC load, DC bulb, DC fan and DC bulb. Okay, so now when you are in some sort of isolated area, some hilly areas where you don't have electricity, just by having this electronic control circuit and a small battery, you can run a DC load. Okay, so here I am taking this DC load as an rheostat. Okay, so now see the connections. So from output of the solar panel, okay, so that is an 100-watt solar panel with terminals of one is positive and one is negative. We are connect control circuit. Technically, this is called charge controller. So this will be operated based on an microprocessor. Okay, this is called microprocessor, and you have some sort of IGBTs. These are called full bridge IGBTs, and this is called as a heat sink. So this is called heat sink. Why? Because equipment will be running for 24 hours. To cool all these IGBTs, you require an heat sink. So this is an aluminum heat sink, and they are pasted with some sort of gum. So this is some sort of gum which will provide insulation. Okay, so in such a way that the equipment can be run for continuously for 24 hours. Okay, so this coming to this how to take this DC supply, how to give to the load, how to perform all this charge. I mean, what is the purpose of this charge controller? This charge controller helps the battery from overcharging and over discharge. So by using this microcontroller, so this will protect the battery from overcharging. So it will not overcharge and it will not discharge less than 5%. It will not over discharge. That is taken care by the program which is there in this microprocessor. Okay, so how to operate all this? Some program is written and they are interconnected with these IGBTs. Okay, so this is how an internal you can see a charge controller. Internally, this is called electronic control circuit. In technically, we call this as charge controller. So to boost up the voltage, sometimes you require a capacitor to be connected in parallel, and all these are basically, you know, that these are nothing but resistors to create the required voltage, and these are nothing but capacitor. Wherever you want to boost the voltage, it will act as an buck converter and it will act as an boost converter or buck boost converter also. All these things is handled by this microprocessor. The program will be already flashed in this software and hardware, and the software it will be flashed into this microprocessor and will be inserted here. So there is no need of any computer. So depending upon the input, automatically it will act. So now when you connect this, so this is after connecting the board. So when you close this board, you can see here, you know what is blinking? Green light. What the light is still showing? Green light. So green light is there means what is the meaning? That solar radiation is available. Now it is working with solar. Solar is available. Next one, you can see the symbol, green color symbol. Sorry, yellow color symbol where it is indicating battery is charge. So you can see here we connected the two input to the solar and one is to the positive of the battery, one is negative of the battery. We are connected to the battery. Okay, so now when you connect it to the battery, what's happening? The battery is getting charged. So now we need to measure the voltage and current. Okay, so we are going to measure how much voltage this is supplied by the battery and how much current is supplied. We are going to put some variable load and we are going to calculate the maximum power supplied by this charge controller. Actually, you have to keep some DC load, but rather than DC load, we directly kept a variable rheostat where you can adjust the resistance. So now how to give the connections is, so we have taken the input and we are connected to the battery, and the output of this load we had connected. So output of the load we are connected to the battery, and from this load we are connected to our basic protection. So for example, if any short circuit occurs, we are provided the basic protection with an fuse, and output of the fuse is connected to an isolator where you can make the equipment on and off, and output you have been taken and we are connected to these two terminals. One is blue color, one is red color, where this will act as positive, where this will act as negative. So from this, see your circuit diagram. So this is the circuit diagram of your electronic charge controller. So solar panel input is given, battery is given, and it's connected to the load, and voltmeter is connected in parallel. Ammeter and DC load are connected in series connection. So now I'm connecting a positive terminal of the supply to the battery, voltmeter positive terminal, negative terminal I have connected to the voltmeter negative terminal, and from the positive terminal of the battery, positive terminal of the load have been connected to the ammeter. So this is the positive terminal of the ammeter I had connected to the ammeter, and the output of the ammeter I had connected to the input of the rheostat, and output of the rheostat, you can see here ammeter and rheostat are connected in series. The output of the rheostat, so this is the variable resistance, the output I connected to the negative. We can say that this ammeter and rheostat will form an closed path. The circuit is closed. Since the circuit is closed, the current will flow. So now the current will start flowing. So you can see the symbols. What are the symbol it is indicating? Solar is available and battery is getting charged. If you dismantle it, you can see here the lights. This is the green color light what it's indicating, and the blue color, this yellow color light is indicating that the battery is getting charged. This is called the original charge controller. So this is what our experiment is. Okay, so what are the ways, how to interconnect a charge controller, how to interconnect a battery, so how to interconnect a load. Okay, so this is how we are performing the experiment. So let's try to give the power. Yes. Now let's try to load directly with 18 watts load. So I am using a two parallel load. One is resistive load, one is variable resistance. So I will make you to understand in a better clarity. So directly if you short circuit this, there is no effect of this. Automatically the complete load will be there on this lamp. Now we have to calculate the voltage and current. So to start record.